I'll walk through the demo. I think there is also a similar demo from yesterday that I think it's also recorded, but I'll do the same, walk through the same demo again. So, right, so here we have a Go fuzzing example where we have, I will walk again from the beginning. So we have, I'll walk again through the beginning, and I show also the project itself and the Fuzz targets. David, I think you saw it as well, but I'll just start from the beginning. So I'll walk through this quickly. We have a simple Go function here, which is called parse complex. There is a bug here, off by 1. So given the right input, the program will crash, and we wrote, for the sake of the example, we wrote a simple fuzz test that will find this crash automatically. It's using GoFuzz. So this is standard GoFuzz based on, GoFuzz has a couple of engines. GoFuzz, in this case, will use libfuzzer engine, which is also pretty standard and widely used fuzzer, coverage guided fuzzer. So you have to implement function fuzz. The fuzzer will pass pseudo random data to this function, and we are calling parse complex and passing this data along. And using the coverage feedback, the fuzzer will be smart enough to generate interesting data, so it will continue to get more and more coverage until it will hit the crash. Okay, so now let's see how we integrate this fuzz test into running in GitLab CI. Okay, so this is standard GitLab CI YAML. So as we are using any other security feature in GitLab, including a template, like including SAST template or DAST, we include coverage fuzzing GitLab.yaml. Once we include that, we need to, once we include that, actually this adds, so we need to include that, and we need to add another stage, fuzzing stage, which will run after test stage. And for each fuzzing function or fuzz test, we need to create a step which extends fuzz base. And fuzz base is something that automatically included once we are doing this line, including the coverage fuzzing template. So in this step, we're compiling the fuzz target. So this is a standard fuzz target compilation, which you can find on GoFuzz documentation. And then we need to run this fuzz target, the binary, using GitLab, using GitLab CLI. And I think I have some, I think I had a newer version here, but anyway, we need to, GLFuzz, or it should be called GitLab Fuzz, is available also at every step that extends the fuzz base. Here we can use any image that we use for the build project, but we are hosting several handy images at this repo. This is a public repo. It does not hold any source code. It just holds releases of our CLI tool, like binary releases, and also it holds quite a few handy Docker images, which includes several fuzzing engines, because it takes a lot of steps usually to install, like libfuzzer or LLVM. So either the user has those images already, or he can use our images. So here is an image with GoFuzz already baked inside. Okay. So now we can go to the CI/CD, and here we have something I push to master. So now we'll see what happens when we just push new commit to master. And here is something that we'll see what happens when someone opens a pull request. So let's go here. Yeah, so here is the Fuzz test, and we can see that this is someone who's familiar with libfuzzers. This is output of GoFuzz or libfuzzer, and we see that it found the crash, and also it found the input that causes the crash. So actually, it's the word fuzzing. We will have all the test cases and all the crashes that were generated. Currently, we will have it here in the jobs artifact. So here we have, we also have the version of the fuzzer. So we can, in the future, we'll be able to also to reproduce everything again. So here we have just the test cases that were generated. And here we have the crashes. The crash also is, so I think this is something that you already saw in the previous version. And now we have also, because we have the GL coverage report as an output, and now we support it on the GitLab backend Rails. So this is also parsed in this screen. We have a new report type of coverage fuzzing. So again, this is just initial logic that we added in the merge request that I talked about last meeting, and we will add more details here. But the current details screen and how the JSON covered JSON report is parsed. So we can see the scanner provided is libfuzzer. Maybe we need to change it to more accurate, because this is like GoFuzz libfuzzer and not CC++ libfuzzer. The scanner type is coverage fuzzing. Severity, our CLI knows to classify severity for some crashes. I didn't port this part of the code yet, but I'll do that in the next version. So we'll have also severity for some of the crashes. We have a crash state here, and we have also the crash type, which is index out of range, which is exactly the bug that happened in our example. So this is kind of the demo for now. Things that we will add in the future, and just on top of my head is various links and to download crashes, and of course, Sam, you can elaborate on this as well, right? I'm just talking about this screen, so we'll have some links to be able to download the crashes in a more handy way than going back to the artifact screens. We'll have also the button here for the MVC, which is available in some of the issues. For the MVC, we'll have a button here, so the user can download the whole artifacts in one click. And I think in the future, currently we only parse the report, but in the next merge request, in the next version, we also should see this vulnerability in the security dashboard, because currently, as far as I understand, it's not in the database yet. So we only see this in the pipeline security dashboard here. Yeah. So that's so feel free to ask questions. And
yeah, so you just kind of led to my first question, which is, can you see it on the merge request today, or is it not available on the merge request?
Sorry, can you ask again?
That security finding you showed in the pipeline report,
yeah,
does that show up on your merge request as well?
Oh yeah, so on the merge request, what particularly happened in the merge request is that we only ran through the test cases in this particular merge request. So it didn't find any crashes. Just for the sake of the example, to see what happens if there are no crashes. But essentially, what will happen? Again, I'll push this change. Is that what we decided is that in the regression, we will also run a short fuzzing session. So actually, it would also find the same crash, and unless we fix, I'll open another. I'll push this change, and I'll open another merge request with the fix. So you will see that there is no, there is no crashes, and yeah.
David, maybe what you're asking is, we're seeing it on the pipeline view. And David, maybe what you're asking is, if you click on that !1, update parse complex, right below to the right of your cursor.
This one?
Keep going up.
Yeah. Here,
so
security.
Keep going up just a little bit. So that's
yeah.
the merge request. And David, maybe this is what you're asking is, will it show up as a widget? Like we've got the SAST or the DAST.
Would the security scan thing show up, and it would show the fuzz finding from that commit?
And my understanding is most likely not, because we have a separate report type. So we've got a SAST report type, a DAST report type, a coverage fuzzing report type. And the coverage report type, we have not updated a widget to display the results here.
Okay. Yeah, that was the question, is that it's good to see it on the pipeline view. But usually people would look at it here, right? Because you've opened up a merge request, you've pushed code into code got scan. It says it need to be there for next week's customer advisory board. It's more of a question that, can I go there to show that if it's there? And it sounds like what you're saying, Seth, is that implementation is TBD, so it shows up in the security merge request widget. Is that fair?
It shows up on the pipeline page, yes.
Yeah, it only shows on the pipeline page. It
Yes.
would not show up in the MR. Okay.
That's correct. And my understanding is, even those, maybe someone can correct me if I'm wrong, but that merge request widget is kind of a moving target. I think Threat Insights is actually doing away with those widgets to have that as a dedicated page.
No, the widget's staying there. What they're doing is they're updating it to be more accurate and displaying what is the actual state. So like in the case of the video that Marcel made, it said there's like 200 vulnerabilities detected, but really there's not 200. That count includes everything else that had been previously fixed, but they never merged down to master, so it couldn't tell you the delta to say there were only 2 new ones instead of 200.
Mm-hmm.
So they're fixing the functionality, but they're going to leave the widget. Now, when you click on the item, it'll take you to the dedicated page instead of the modal.
Yep.
That's part of their work.
Okay. Yeah, we have not focused
once
on
we get the
widget.
Yeah, once we get the fuzz findings integrated with standalone vulnerabilities, I believe the widget information will start being displayed, because that widget is being driven off of all the standalone vulnerabilities, is my understanding. So it should show up as part of the widget and the security dashboard all at the same time.
Okay.
But that's the part we haven't done yet.
Yeah,
okay.
and yeah, we have to check that, because traditionally those widgets have been independent. So you'd have one for DAST, one for SAST, so on and so forth. And they may have been consolidated into a single widget, but I don't know the latest state on that.
I don't think they're merging them together. I can follow up with Matt on that, because I think it makes more sense to leave them broken out so you can see, well, that was a SAST result or that's a DAST result. But
right.
I can follow up with him on that.
Yep.
My next question is, in your demo here where you're finding the fault using libfuzz or gofuzz, have you enabled SAST on this repository as well? So you could see that SAST didn't detect the problem because it's not a known vulnerability?
Yeah, so let me see.
I think you just need you just need one additional line in there.
Yeah,
like in your included, you can just include the SAST template.
Yeah, so it's not included here. Can include it here. You can see that only the coverage, like the title, is missing here, but only the coverage fuzzing is enabled now. Yeah. So yeah, we can enable it for the demo, I guess.
Yeah, it's a Sam's positioning in his upcoming blog, the stuff he's put on the direction page, really talks about like this finds things traditional scanners don't find, which I think we all agree is the case with fuzzing. But to kind of show that in a quick demo to someone, if we added in the SAST template, SAST would run. I don't think SAST is going to find the error that you're finding of getting, and then it's like you can see here, SAST didn't find it, but because you ran this, you now know there's a problem here.
Yeah. Okay. Sounds good. So I'll add this.
Okay.
Yeah, and I'll so I'll send I replicated the environment on a Google on the GCP demo, so I'll send the link in the channel as well to this, and then let me know either if you want to record it with your own rhythm and voice, then okay. If you want to like me to record it